Okay, Assalamualaikum. My name is Muhammad Tasnim Muhammad Khalis. I am the group leader for this assignment, which is Kajat. Okay, my teammate is Faris, Nurul, Nadira, and Wong Kahau. In the presentation, we will explain about the Kajat. Okay, next. What is Kajat? Kajat is a mechanical lifting device to lift or jacking up heavy objects, such as car, lorry. Okay, next is we go to the history. Okay, if we go back to history, in 1851, the first jet was invented by Richard Duggan and patented under the name portable hydraulic press. Hydraulic jet, a jet which proved to be significantly superior to the jet in use at the time. Okay, for scissor jet, the machine was invented by Joseph Lafrance, who is Canadian. He was submitted his design for a diamond-shaped jet in Montreal, Quebec. Okay, next, why we choose Kajat? Okay, because it has three mechanical components, which is fastener, shaft, and well. Thank you.
My name is Wong Hao. Now I will explain the weld part. A weldment is fabricated by welding together a collection of metal shafts. During welding, they are held together by clamping or jerking. The commonly used welding are MIG, TIG, stick, and flux. There are many different types of welds which are best described by their shape when shown in cross-section. In this case, fillet weld is used. It is as strong or stronger than the base metal if weld correct size and proper welding technique used. With less skilled welders, this can lead to the penetration or fusion defects that cannot be detected by visual examination and other non-destructive testing. It has three contours which are concave, convex, and flat. The second figure shows the weld symbol and weld is go around. This figure shows the weld part in the real product. Next, I will explain the fastener. It can mechanically join two or more objects together. Fastener usually used to create non-permanent joints which are cause no damage to the parts. Different fastener has different characteristics. The most used materials are carbon steel, alloy steel, stainless steel, and aluminum. Threaded pin joint is used in this case. It is used to keep two or more elements in alignment or relative to each other. Since the pin has no threaded at the outer surface, it can allow for rotational movement. They are cylindrical shapes and subjected to tension instead of compression. In this case, it has a threaded hole in the middle of the pin to allow the shaft pass through it and support the mechanical system. Besides, tubular rivet also used. It considered as permanent fastener because removing it will destroy them. It gives a lot of hollow tube that is inserted to the hole. It is stronger than other rivet. The figure shows the rivet part in the real product. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Component 3, shaft. Shaft is a circular cross-section rotating machine element and were used to transmit power or motion. Transmission shaft is a circular shaped shaft that support transmission element in machine and transfer torque from one machine element to another. The shaft that used in scissor car jet is screw shaft. Screw shafts provide a compact means for transmitting motion and power. They are ideal for replacing hydraulic and pneumatic drive systems as they require no compressors, pumps, piping, filters, tanks, valve, or any other support system required by this system. Furthermore, screw shafts do not leak, so there are no problems with seals which are so common to hydraulic and pneumatic systems. Important terms that need to be understood before designing screw shaft. First, pitch. Pitch is the distance from a point on one thread to the corresponding thread on the next adjacent thread that were measured parallel to the axial plane. Second, lead. Lead is the distance the screw will advance relative to the nut in one rotation. For single-threaded screw, lead is equal to pitch. Third, helix angle. Helix angle is related to the lead and the main radius. Screw shaft motion. There are four distinct motion converting actions that can be produced by screw shaft and nuts. The two most common involve torque conversion to thrust. The screw shaft is rotated, torque, and the nut move linearly. The two less common motion involve thrust conversion to torque. The nut undergoes a linear force thrust, and the nuts rotates. These two motions are commonly referred as backdriving, overhauling, or reversing. Type of thread. First, square thread. Square thread is used for power transmission in either direction, result in maximum efficiency and minimum. It's employed in screw shaft jacks and clamps. Second, Acme thread. It is a modification of square thread. Efficiency is lower than square thread. The slope increases the area for the shear. It is easily manufactured. Third, buttress thread. It is used when large force act along the screw axis in one direction only. It has higher efficiency like square threads and ease of cutting like Acme thread. It is the strongest thread of all. It has limited of power transmission. That's all.
Hi and Assalamualaikum. My name is Ahmad Faris, and right now I am going to talk about CAD drawing section. First, we measured each of part from the actual product using ruler and caliper. Then, we sketched the actual product on paper and put on all the dimensions that we took before, so it will be a guide for us to draw it on CAD. Lastly, we draw the product on CAD using SolidWorks. The next part is the drawing section. The first one is the technical drawing of assembly view. It consists one whole product and we label all of the components. The next one is exploded view. It shows the separated part of the assembly view. This is important to show the hidden part that cannot be seen in the first drawing. Then we have the mechanical component. The first mechanical component drawing consists of shaft and weld. This is the actual drawing of the screw shaft, and it has a weld between the shaft and the handle. After that is spin. This is the drawing of fastener spin to join the lower arm and the upper arm of car jack. And lastly, we have a rivet to match the top header and the base of car jack with the upper arm and the lower arm. That's all from me. Thank you.
Here are the sample calculations for the scissors car jack. Figure 2 shows the free body diagram of the top section. Figure 3 shows the free body diagram of the joint of the shaft and arms. Torsional stress in the screw shaft. Factor of safety. The material that we use for this scissor jack is AISI 1045 carbon steel that has the following properties that can be obtained from SolidWorks simulation. The properties that can be obtained such as mass density, tensile strength, yield strength, thermal expansion coefficient, thermal conductivity, and specific heat.
Conclusion. We managed to analyze every part of the mechanical component in the car jack and apply the knowledge learned from the class. Every part of this component plays an important role for car jack to function. Without the fastener, the product would not be assembled. Without the shaft, the power would not be transferred to lift car. And lastly, without the weld, different parts would not be joined together. In the end, we hope this product can be developed to more sophisticated car jack that can do more than just lifting the vehicle based on our analysis. That's all. Thank you.